I'm Bird, and I'm going to be talking to you about my science lesson. First, I want to show you this cavity. So this is a nest cavity, and my lesson centers on woodpecker nest cavities. This happens to be a black-capped chickadee cavity, and it's active, so we're going to go a distance, a little short distance away from it to talk more, but I wanted to show you what a nest cavity looks like because I realize maybe not everybody knows what a nest cavity is. I have to go all the way over here. So for my lesson, I'm going to have students making observations and measurements of nest site characteristics for woodpeckers in post-fire habitat in Crater Lake. So this is actually something I'm working on developing with the Klamath County School District for part of my dissertation. And the idea behind it is that it's giving students inquiry skills, so they'll get to go out and make observations and hypotheses, and then ideally the next field season they'll get to collect some data on those hypotheses. We'll see if that's how it works out. But so for this lesson I have two activities. One of the activities is a scavenger hunt where they're using the tools that they will be using in the field in order to work their way through the scavenger hunt. And I modeled the scavenger hunt after the Valley Quest model, which was talked about in David Sobel's book a little bit. We actually have a version of that for the Oregon Coast, and I have an Oregon Coast Quest book and I love it. So I figured, why not model the scavenger hunt after this rubber stamping clue, exploring your neighborhood idea. So in the scavenger hunt, the students use the tools to navigate, certain distances or to find a tree, and they have to record the DBH and use all of that information later, but there are also stamps at each of the stops. So the whole Valley Quest, Oregon Coast Quest thing is that you earn stamps, and then you get a prize after you earn all these stamps. And so the students earn stamps along their scavenger hunt, and then ideally the teacher provides them with a prize at the end of the scavenger hunt. So that's one activity. And then the other activity has to do with actually monitoring woodpecker nests. So the idea behind that is that in this case, I will have gone out and identified woodpecker nest cavities, and the students will go back out and use GPSs, like this one, to find the nests that have already been marked, and then they will make observations from a distance like this so that they don't interfere with the birds. A lot of cavity nesting birds, if you go sit right into the cavity, they won't go in to feed their babies. It doesn't matter how long you sit there, they'll just wait for you to go away because they don't want to give away where their nest is. So if we have the students stand several meters away, the birds are less likely to have their behavior changed. And then characteristics that they would record any behaviors that they see for the woodpeckers. So, are they feeding the babies? Are the babies sticking their heads out of the nest? Are the parents flying around making a bunch of noise and trying to chase the students away? And then, so they make those observations. Ideally, in a dream world, they'd get to go out once a week until the young actually left the nest, so the students themselves could record whether or not the nest was a success, meaning the young left, or a failure, meaning the young were either eaten or died. But in this activity, I have them just visiting it once. And then they'll record things like the DBH, so the diameter breast height, which David demonstrated earlier in the term, and they'll be measuring nest height and snag height. So one of the reasons that that's an important measurement is that there's some belief that there are differences in height and orientation of nest cavities between woodpecker species, and it's it's one of those things. A, it's good for math. B, it could be good for their own hypothesis development and data collection and observations. So, and then they'll be gathering the aspect, which they'll do with compasses. And so I have my compass here. I realize not a lot of people know how to use a compass correctly, so I figured I would try to do a short demonstration on how to use a compass. So one of the things that we say a lot is keep the red in the shed, which doesn't make a lot of sense if you don't know what the shed is. So the red is referring to the north arrow, and the shed is kind of like the north arrow's home. And you know when the red is in the shed, so when you sent the north arrow home, that your arrows are now lined up, and so whatever degrees is on the compass is like what degrees you're actually facing. So for the chickadee nest, we're really far away from it now, but we would go, to measure that, you'd put your back up against the cavity, and then you'd say, oh, so if the cavity was behind me, I would turn this, and then this thing here turns. It has a name, I can't remember what it is. And you turn it until the north arrow lines up. And this mirror is real cool because you can use the mirror to see so you don't mess up the compass. Use the mirror to see if they've lined up or not. And then to make sure that that you're facing the correct way, you bring the compass up to eye level, which we call sighting. And there's this little notch here, and there's this line in the mirror. And basically what you do is you make sure that your red's in the shed, and then you look through the compass, and when the line is through the notch, whatever's in this notch here is directly, 254 degrees from us, or facing 254 degrees. And then we would know the nest orientation is 254 degrees. Anyway, hopefully that wasn't too confusing. Anyway, so those are the activities. The other thing I wanted to show you, because I use this in the field all the time, is this cool clinometer app. So one of the things that I found most convenient about doing orienteering courses is learning how to pace. So part of the scavenger hunt is having the students learn how many paces they have per 50 meters. So then they can use their own stride in order to measure distances from things. So what I would do in the field, because I think it's easier than navigating some of the string measuring devices they have for foresters. Those get tangled up and I don't like using them. So I would stand with my back to the snag, and then I would pace my way to where I'm standing and say, oh, this is however many meters from that tree. And the cool thing about this app, which is called Theodolite, unfortunately you can only get it for Apple products. So the cool thing about the app is, A, you can take pictures, and it will actually tell you what direction you're facing. Wait, where's the tree? Oh, there's the dogs. Is the sun on that too much? Yeah. So,
no, it's too dark.
It's okay. So the way that you use this is basically you say, I am, 12 meters from that tree. And you take a mark at the bottom, so that's A. So we know that that's the bottom. And then normally you'd be able to see the cavity. We know the cavity is right about there. You mark that as B. And you say calculate. And I'm just going to say that we're 12 meters from the tree. I did not pace it today. And so then it gives you a height. So that means that cavity, if we were 12 meters from that tree, the cavity would be 3.3 meters above the ground. So I like the idea of introducing students to some of these technological apps, in part because so many organizations are moving toward the use of tablets or iPads or iPhones or things like that in the field. And it's really convenient to be able to have your GPS and your compass and your clinometer and your field note-taking devices all in one compact device rather than having to fill your backpack with stuff. So I like the idea of teaching students about some of the technology we have out there. And I think that's probably it. Thanks.